Alright, so let's finish up with the fourth marking period. First part of this video, we're going to talk about rational functions, rational expressions, and rational equations, and then we'll talk about polynomial expressions and polynomial equations. So here they want to have a rational function that has vertical asymptotes at -4 and 2. So remember that vertical asymptotes come from excluded values after the expression's been simplified. So all these are simplified already. So all we got to find is the excluded values. Remember, excluded values are values for the variable that would make the denominator equal 0. So what we're looking for is which function would, when I plug in -4 and 2 for x, would make the denominator equal 0. Well, it's clearly not b, and it's clearly not d, because we want the denominator to equal 0 with -4 and 2, and -4 and 2 on b would make the numerator equal 0, and d wouldn't even make the numerator equal 0. Anyway, so the answer here is A, because if I plug in -4 and +2, it'll make the denominator equal 0 on this one, and those create vertical asymptotes. Let's hop over to number 3. Here we have a garden, and we're trying to find the area. Well, remember that area is length times width, so we're just multiplying these two fractions together. All you got to do here is factor and cancel. Number 4, we're solving a rational equation, so you have two choices. You could cross multiply. When you cross multiply here, though, you end up with this extraneous solution over here. The other option is to multiply both sides by the LCD, which is what I would recommend. The LCD is x squared minus 1 here. So when I multiply both sides by that, I'm going to end up with 3 times x minus 1. And on the right side, I'll end up with 1. And then if you just solve that, distribute, isolate x, you'll get x equals 4/3. It's just a little bit simpler. Scrolling down to number 5, we're simplifying, then state the excluded values. But remember, you have to really state the excluded values before you simplify. There's actually an excluded value missing here. X can't equal +5 as well. So all you're going to do here is factor and cancel. So when you have a single fraction like this, or if you're multiplying like number 6, or dividing like number 7, then all you're going to end up doing really is factoring and cancel. 6 is just straight up factor and cancel. 7, because it's division, I have to keep, change, flip first, and then factor and cancel. So number 2 over here, we're graphing a rational function. So the first thing we want to do is see if it simplifies. And it actually does simplify here. Now the consequence of that is there's going to be a hole. So think about the excluded value that would have been in this factor had I not canceled it out, and that's +1. That's where the x coordinate of the hole comes from. To find the y coordinate of the hole, we just plug in 1 for x and what's left. So I'd get 1 minus 2 over 1 plus 2, which is -1/3. So the hole is at -1/3, and you can +1, comma -1/3, and you can see it's right over here. To find the vertical asymptotes is the excluded value that remains. So what would make this term equal 0 is -2. Horizontal asymptote, it's probably easiest to look at the original. For a horizontal asymptote, you're going to compare the degree, and there's 3 cases. If the degree of the numerator was bigger, there would not be a horizontal asymptote. If the degree of the denominator was bigger, it would have been y equals 0 automatically, but this is the case where they're the same. So what you do then is divide the leading coefficients to find the horizontal asymptote. So 1 over 1 is 1, y equals 1. To find the x-intercepts, you find the zeros of the numerator. The only 0 in the numerator here is 2. To find the y-intercept, technically you plug in 0 for x, but when that happens, you're just going to get the constant term divided by the constant term, which is -1. So then I plot all this information. Here's some extra points just added to the graph. They're not totally necessary, but if you're not sure what the picture looks like, you're going to use these. So just plotting this information here, which would have been the y-intercept, the x-intercept, the hole that's right here, this vertical asymptote here, the horizontal asymptote, you can see which way it has to go. First of all, it's got to hug this horizontal asymptote at the end. Horizontal asymptotes are end behavior. So that means it's either got to hug here and go down the vertical asymptote or up the vertical asymptote. Since there's no x-intercepts here, the only choice for this graph is to come up the vertical asymptote. Oops. Then if it starts up here, if it ends up here, it's got to start up again on the bottom. And it's got to hit the y-intercept, hop over the hole, hit the x-intercept, and then hug the asymptote over here. If you're looking for more information on that, you have a whole typed up worksheet that tells you how to find all this information. Scrolling down here, let's finish up with the rational stuff. Number 8, we're adding. So whenever you add, you got to make sure you have a common denominator. We already have that here, so you can just add the numerators. And then after you have a single fraction, you should, just like before, see if it factors and cancels. So this simplifies to 2. Now number 9, I don't have a common denominator, so I need to make one first. You should notice that they don't have any factors in common. The denominator of the first fraction is 8x plus 1. It doesn't factor. The denominator of the second fraction is 2x minus 1. It doesn't factor. So when I add and subtract, I have to multiply by what's missing. This first denominator needs 2x minus 1, so I multiply both numerator and denominator. This over here, this fraction needs 8x plus 1, so I multiply numerator and denominator. So then all I got to do really is multiply and combine the numerators. Just be careful of distributing the negative 5. On the left's a double distributive property, and just combine like terms, and there's your common denominator. Number 10, first thing I'll do, again, is subtracting, so I need to find a common denominator and then multiply by what's missing. So when I the first denominator doesn't factor, but the second one does into these two factors, x minus 9 and x minus 4. So they both have x minus 9 already, but this has an extra x minus 4. So I need to multiply the first fraction on the numerator and the denominator on both of those. Well, I just pointed those backwards, but you get the idea. So that would be my common denominator, x minus 9 times x minus 4. So in the numerator, you're just going to distribute the 7. And don't forget to spread the negativity here. This negative has to go to both terms. So the negative 5 becomes positive 5. And then just combine like terms. Now number 11 and 12, you are solving. So the easiest way to do these is to find the LCD and then multiply each term by the LCD. So here the LCD is 6x. So I multiply each term by 6x. 6 over 2 is 3, that's why I have 3x. 6 over 6 cancels out, so I have x times x, which is x squared. And over here the x's cancel out. 18 times 6 is 108. Now I can see it's quadratic, so I want to solve using a quadratic technique. Here I decided to use the solve by factoring. And if either one of these solutions was an excluded value, I'd have to cross that out because it'd be an extraneous solution, but we're okay here. Same thing on 12, multiply every term by the LCD, and then it's quadratic again, so I decided to solve by factoring. Number 3, they've given you the area of the carpet that's a rectangle, and they want to know, oops, one too far. And they want to know, they give you the area, they give you the length, what's the width? Well, area is length times width, so if I have the area, I'll divide by the length to get the width. So you're just dividing these two here. And when you divide, you're just going to factor and cancel, and that's what we did here. So moving on to polynomial functions. Number 14, we want to find all the zeros. So here we are on zero quest. So you want to use Descartes' rule of signs first. Count the number of sign changes in g of x, and you can see it goes from positive to positive to negative to negative. So it only changes sign once, so that means there's only going to be one positive 0. That's good. So when we go to look for zeros, we know to look for a positive one first because there's only one. When I do g of negative x here, only the odd degree terms actually change signs. So 1x cubed becomes negative x cubed. 2x squared would stay the same. Negative 11x would become positive 11x, and negative 12 would stay the same. Now you can see there's 2 sign changes, so there's going to be 2, keep going down by 2, or 0 negative possible zeros. So then when I make this chart, I go through all the possibilities. It could either be 1 positive and no negative, which leaves room for no imaginary, because it's got to add up to 3, which is the degree, which is the total number of solutions. Or it could be 1 positive and no negative would leave room for 2 imaginary. Remember, imaginaries always come in pairs, so you should never have any odds over here. It should be 0, and it should, or an even number, when 0 technically is even. The rational root theorem, which is right here, you want to find the factors of the constant term and divide them by the factors of the leading coefficient. Well, since the leading coefficient is 1 here, I just end up with the factors of the constant term, and don't forget the plus or minus. So then because this is cubic, I only need to find 1 0 by synthetic division, and negative 1 works here. Now what's left is quadratic, so I can solve that by factoring, and here are the 3 zeros. Number 15, graphing this, the first thing you want to do is pick out all the zeros, so negative 3, 4, and negative 1. You want to notice that x plus 1 squared, so negative 1 is a double root, so it's going to bounce there. To figure out the degree, we got to think about if we multiplied this out. So all you really need to do is add the exponents on the parentheses. So 1 plus 2 plus 1 is 4. So it's got even degree. That means it has the same end behavior. You can see the leading coefficient's positive, so that means it's going to end up. And since it's even degree, we'll have the same end behavior. So I'd start here, cut through the first 0, then it's going to bounce at -1, come back down, and then come back up through 4. Number 16, I just want to know what polynomial function would give this graph. So what I would do is pick out the zeros of -3, 1, and 2 and make their factors. And the only thing to notice is that -3 it bounces, so I make that squared. Now they're not asking us to solve for a, but if they did, I would have used this point here and plugged it in for x and y and solved for a, but you don't have to worry about that. Scrolling down, write a quadratic formula with these zeros. So one way to do it is just come up with the factors here. The factor for -5 would be x plus 5. The factor for 1 would be x minus 1, and then double distributive property that. Or, because this is multiple choice, I could plug in -5 for x and see if it comes out 0, and then plug in 1 if it sees it and see if it comes out 0. 16, you're multiplying monomials and then dividing by a monomial. So when you multiply monomials, you multiply the coefficients and you add the exponents. Then when you divide, you simplify 16 over 4 like a fraction. Well, it divides unevenly here, and you subtract the exponents. Biggest mistake on number 17, first of all, notice you're subtracting. People will multiply on this. Not only will they be wrong, but they'll have done extra work. Just don't forget to spread the negativity here. This negative has to go to all these terms in the parentheses. So you can see right here, positive 6x squared becomes negative 6x squared. Negative 4xy becomes positive 4xy. Positive 3 becomes negative 3, and then combine like terms. What's the degree? Well, that's the highest exponent on any of the variables. So you can see here it is 8. What's the end behavior on this? Well, we got to consider the degree and the leading coefficient. The degree is odd, so we know it has opposite end behavior. So just looking at the answers, is you can throw out B and throw out D just based on the end behavior has to be opposite. And then if you look at the leading coefficients, it's negative, so it's got to end down. So that leaves the only choice C. 20 is one of the graphing ones like we just did. Grab the zeros, and then notice that it ends up, so it should have a positive leading coefficient, and that makes the answer D. The zeros are -4, -1, and 2, so the factors are x plus 4, x plus 1, x minus 2, with the positive leading coefficient. Number 21, there's a couple things that are important here. When I have a monomial to a power, I'm actually going to do 2 to the third power, which is 8, and then I'll multiply the exponents. From there, I will just, a couple ways to handle this. The way this was handled here, I got the negative exponent, so I can just move it to the other part of the fraction, and then 2 times 9 is 11, add the exponents. The other option is to do 9 minus -2, which would make it 11. And don't forget, you subtract the exponents when you divide. Here I'm finding the perimeter, so there's a few different ways to do this. One, I could have filled in those other 2 sides and then just added up all the sides. The other way to do it is what's done here, and multiply each side by 2 separately and then add them up. And the last option would be to add these 2 sides and then multiply that by 2 with the distributive property. Here we're finding the area, so it's just length times width, and we're doing a double distributive property. Couple more. So name the degree. Well, you should notice that they gave you the function down here, so I can figure out the degree by just looking at this function. You see the degree is 4. Degree always matches. The degree always will match the number of solutions. Those should always be the same number. The number of real solutions is because there's 2 X-intercepts and there's no bounces, so they each count once. And then to figure out the number of imaginaries, you just subtract the number of reals from the total number of solutions. 25, we're sketching the graph again, so pick out the zeros, the roots. -5, 2, and 4. Notice 4 is going to bounce. Negative leading coefficient means it ends down. The degree here is you can add up the exponents on the parentheses, so it's 1 plus 1 plus 2 is 4, so it's got the same end behavior. So it's also got to end down, so it's definitely got to cut through, come down here, cut through, bounce, and then go down. Dividing by synthetic division, just remember here when you're dividing, you actually flip the sign here, so this is +2, I make it -2. All the coefficients go across from the numerator. Just make sure that you don't need any placeholders. So the first term always just drops down. -2 times 4 is -8. 6 plus -8 is -2, and I just keep that pattern going. -2 times -2 is 4. -6 plus 4 is -2, and you just keep going like that. So when you're done, this last term will be the remainder. And since I divided by x to the first, all these terms will go down 1 in degree. So this used to be 4x to the 5th. This will be 4x to the 4th, and then just work your way down. -2x to the 3rd, minus 2x squared, plus 5x, minus 13, plus the remainder over what I divided by. Find all the zeros. So I could use Descartes and whatnot here and the rational root theorem. So you find 1 0, and because this is the fourth degree, I need to find 2 before it's quadratic. Don't forget to use the depressed polynomial here and just keep going from there. And then the last 2 zeros here, we had to use the quadratic formula to find them because they were imaginary. And that's it for marking period 4. So good luck on the final.